Hi everyone. Make sure you have a pen, pencil, and paper. No calculator necessary for now. And we are going to start our last piece of a huge trigonometric unit. This is actually a culmination. It uses a lot of ideas you've learned so far. We will use graphs, we will use special values, we will definitely use our understanding of a unit circle. And we will start with very simple ones. So let's go. Cosine x equals 1/2. Just think right away what will be the angle, reference angle, whose cosine is 1/2. Did you say 60 degrees? Yes, good. Or even better, pi over 3. We are going to look at multiple variations of the answer. The solution will depend on what interval we want. So you said x equals 60 degrees. All right, fine. Let's start with degrees, and hopefully you understand that this is just a reference angle. So take a pause and think what are other angles whose cosines are 1/2. Hint, draw unit circle. Okay, so sorry, my circle is a little crooked. Cosine equals to 1/2. So cosine is our x value. On the x-axis, between 0 and 1, you have this 1/2. I actually want to mark this number. This is our 1/2. So one angle whose cosine is 1/2 is 60. Here you go. So this is 60 degrees. And hopefully you understand that another angle where cosine is still positive will be in the fourth quadrant. So what I'm drawing now is really important. This is your method. This is the strategy that we are going to use. So what's the value of this angle? You can call it many different ways. You can say it's negative 60 degrees. Or if you want to stay positive and just go from 0 to 360, then think what angle it is. It will be 360 minus 60, so that will be 300 degrees. And you can call it many other ways. So let's basically do the same thing in radians, and then we will say how to give an answer. So this would be either pi over 3 or negative pi over 3. Now, what is 300 degrees? So pi over 3, we have 1, 2, 3 of them, 4 and 5. So this is 5 pi over 3. Okay, we will have better ways to figure it out, but for now, this is good enough. And then we can go on. So let's solve this problem using many different requirements. Okay, so let's look at the first case. We just want solutions from 0 to 360 or from 0 to 2 pi. We already said that our answers will be in degrees, it will be 60 degrees and 300. We can put those braces, it's a set notation. Or if we are in radians, we will say pi over 3 or 5 pi over 3. Now, in radians, same thing. We can write, from negative pi to pi, we can say, so negative 60 degrees and 60 degrees, or in radians, or we can just say plus or minus pi over 3. We could also say plus or minus 60 here. This is kind of important because what we're going to do now, we'll try to write all these solutions in a single short expression. And this format actually gives us an idea. If you start with positive 60 and negative 60, then we can get the rest of the solutions by going around the circle from here, plus 1 full cycle, plus 1 full cycle, and so on. And we can also do it for negative 60 degrees. So we can start writing this. 60 degrees plus, we can add plus 360, plus 360, plus 360. So we can add 360 any amount of times, and this n could be also negative. So we say n is any integer. And integer, once again, means 0 plus minus 1 plus minus 2. We don't need to write it every time. I'm just reminding you. And also, we can go from negative 60 and add any amount of full circles. So negative 60 is good too, plus 360 degree n. Now, the good thing, we can combine this into a single shorter expression, plus or minus 60 plus 360n. We will mostly use radian format, so that our answer will be x equals plus or minus pi over 3 plus 360, it's one full cycle, so it's 2 pi n. Now, to better understand what it says, let's see. If n equals 0, then we are not adding anything here, right? It's just plus pi over 3 and minus pi over 3. If n is 1, we are going to add to pi over 3, we are going to add one cycle, 2 pi. So it will be 2 pi plus pi over 3. We can combine them, but we really don't care. And also, we will look at negative pi over 3 plus one full cycle. And then we can do it for more cycles, or we can go backwards. If n equals 1, we can subtract one full cycle, so it will be pi over 3 minus 2 pi, and we can keep going in both directions. Just to kind of solidify and to illustrate once more why it makes sense. So let's think about the graph of cosine, roughly, okay? Now, our question is, when is cosine equals to 1/2? So cosine is our y value, so 1/2, this is 1, but we want to see when it's 1/2. If you draw this horizontal line, you can see how there are infinitely many intersections. I don't want to go into too many details here. We know it's a 2 pi, right? So these are our solutions in the first cycle. This is pi over 3, and this is 2 pi minus pi over 3, or the same as pi over 3, negative pi over 3 plus 2 pi. 5 pi over 3. Let me say it again. The other way to get this number would be to get 2 pi minus pi over 3. As you see, we have pi over 3 from 0, or we pi over 3 from 2 pi. You can see it very well either from the graph or from the unit circle. But it's actually the same as minus pi over 3 plus 2 pi. So no matter how we look at it, it kind of makes sense. And then if you go to the next cycle, it will be 2 pi plus another pi over 3, or 4 pi minus another pi over 3, and so on. And we can go to the left. This is your negative pi over 3, and so on. I believe that using unit circle is easier than using the graph. But first of all, graph gives you a very good visual representation, so you can understand what's going on. And the best thing, you can check yourself with a calculator. There will be more complicated equations, and you can always type the function on a calculator, and let's say right side and left side, or whatever your function expression is, equals to a number, whatever that number is on the right. Draw a graph with a calculator, draw that line, and you can actually see how many solutions you see, and so on. Okay, so this is just one case, cosine 1/2. Let's move to the other functions. Okay, so the next equation will be sine x equals 1/2. Stay for a second, just pause for a second and think what are some values where sine equals to 1/2. Okay, I guess you remember it's 30 degrees or pi over 6. This is the reference angle. Okay, but we already smart and know that there must be more angles than just one. So let's do the same thing we did in the previous case. So I actually want to show this sine equals 1/2 on a unit circle. Sine is the y coordinate. So this is 1 and this is 1/2. So one angle whose sine is 1/2 is 30 degree. This is our 30-degree angle, right? Or pi over 6. But another quadrant where sine is positive is second. So we can extend this line to the left and see where it hits the graph. And it will be 180 minus 30, which is 150 degrees. Or it will be pi minus pi over 6, or you can count 1, 2, 3, 4, 5. So 5 pi over 6. So if we want solution from 0 to 2 pi, I guess I'll stick to radians for now. Then you can just say it's either pi over 6 or 5 pi over 6. And we are good. Oh, yes. Now, what will be harder? I'm going to skip from negative pi over to pi. We don't usually use this. So we will look at all solutions. And this will be a little tricky. Ready? All right, let's go. So, if we want to start with 30 degrees, actually, let's stick to radians, pi over 6. Then we want to keep adding one full cycle, another full cycle, or subtracting. So again, we can use any integer number of 2 pi's. So this gives us one series of solutions. To get the second series of solution, we need to start here at 150 or 5 pi over 6 and going again either way, full cycle, either way. So it's 5 pi over 6 plus 2 pi n, and that's a second series, which is not bad there. So for now, we are just going to stick to this format, and eventually we are going to work out a more economical way to write it down, but it's pretty confusing, so I don't want to scare you now. And most of the times, anyway, we are going to just find answers within the first interval. So for now, it should not be too bad. Okay, let's try negative values now. Draw your own unit circles and show two angles on a unit circle where cosine is negative radical 3 over 2. We are focusing on this one for now. Don't look before you actually do it by yourself. Okay, so hopefully did. Cosine is negative, and it's negative radical 3 over 2, so it's a big angle, and hopefully you know the reference angle. But even if you don't, because we won't always have nice angles, you understand that cosine is negative in the second and fourth and third quadrants, and we are drawing this really important segment every time. So this is this catches two angles where cosine is negative radical 3 over 2, and these are our angles, and we want to describe them. So what's the reference angle? Did you figure it out? Okay, so the reference angle, if you think about the positive value, is 30 degrees, right? Or pi over 6 again. Okay, so no, that does look right. You know what? I wanted to erase it and rewrite this piece, but then I thought it would be useful for you to see what doesn't look right. You see how my angle here doesn't look like reference is pi over 6. So it will be confusing and misleading. So I'm going to erase this circle and draw a new one and start over. Okay, so hopefully this one is better. Where are we? Okay, so negative radical 3 over 2, and still not too good, but at least here we can see that the angle is really small. It's important, guys, so try to draw your diagrams neatly and make your angles look realistic. Okay, so the reference angle is pi over 6, so our angle will be again pi minus pi over 6, so it's 5 pi over 6. Now, for cosine, everything is nice actually, because this is pi over 6 and this is negative pi over 6. So our solution, as we saw in the general formula on the previous page, will be plus or minus 5 pi over 6, and don't forget to add whole number of cycles. That's it, finished. 2 pi n. Okay, so let's look at sine angle now. Sine is negative radical 3 over 2. Sine is the y variable, so if this is negative, not variable, value. So if this is negative 1, negative radical 3 over 2 is 0.866, so it's somewhere around here. And we are going to draw now this line horizontal. Sine negative is in the third and fourth quadrants, okay? So we are going to draw this angle so we can see them better. What are them? Now, the reference angle is pi over 6 pi over 3 this time, right? Now, we don't really see pi over 6, but we know that this is negative pi over 6. So we label it, negative pi over 3. Okay? Now, what is this then? There are a couple ways to go about this. If we want our solutions from 0 to 2 pi, for instance, then it's actually harder, because what we need to do, we need to find this angle, negative pi over 3. It's not from 0 to 2 pi, right? So if you start here and you go, what is this angle? It will be, so let's just divide it in pi over 3s and see what happens. 1, 2, 3, 4. So it's 4 pi over 3 or 5 pi over 3. These are our two options. Maybe I should do it in degrees to show it's a little bit easier. In degrees, so this is 180. This is 180 plus 60, which is reference angle again. So this will be 240. Plus another 60, that will be 300 degrees. Okay, so answer will be 240 degrees or 300 degrees. And if we want all solutions, for now we'll just say either we start at 240 degrees and then keep going 360 n, or we start at 300 degrees and keep going 360 degrees n, or if it's in radians, then it will be 4 pi over 3 plus 2 pi n, or 5 pi over 3 plus 2 pi n. We have to present both of these options, because otherwise we will just lose half of the solutions. Again, we are going to work out a more effective way to write it down. Okay, let's see what happens with tangent now. Okay, so tangent actually is the easiest one to use. You will see why. So tangent equals 1. You know that reference angle is 45 degrees or pi over 4 if it's in the first quadrant, but if it's where else tangent is 1. So hopefully you remember my tangent line, and we can extend this to the third quadrant. That's the other one where tangent is positive. To get here, you need to add half the cycle, or pi, or 180 degrees. So pi plus pi over 4 is 1, 2, 3, 4, 5, or pi plus pi over 4, we can just write, is 5 pi over 4, or if you're at degrees, it's even easier, 180 plus 45, so it's 225 degrees. So that gives us our two solutions, actually, two series of solutions. It's, you can write pi over 4 plus 2 pi n, also 5 pi over 4. But you know what? It's actually silly, because you can see that you can get from one of this, you can get to another one by adding pi, plus pi, plus pi, plus pi. So you see, the solution actually becomes much easier. It's pi over 4 plus what? Yeah, pi n. That's it. When n is any integer. Nice. Let's see what happens with a negative angle, a negative tangent. So tangent is negative radical 3. What's the reference angle? Think quickly. Reference angle would be 60 degrees or pi over 3. If we visualize it on the tangent line, tangent is negative in the second and fourth quadrant. Radical 3 is approximately negative 1.7, and we know it's negative 60 degrees, something like this. Sometimes negative 60 degrees is okay, but usually we want answers positive, starting from 0 and up. But let's find the other solution first. So the other solution is in the second quadrant. And again, if reference angle is 60 or pi over 3, then this will be 2 pi over 3, or it will be 120 degrees. And so maybe this is okay. If you want solutions from 0 to 2 pi, then this is our answer. Not yet. So 2 pi over 3 is actually the smallest one, because we are going from 0 to 2 pi. So first we encounter this one, which is 2 pi over 3. And how many pi over 3s is this? It's 2 pi, take away 1 pi over 3. So it's 5 pi over 3. So these are your solutions in the first cycle. Or if you want all solutions, you can start with any of them. Let's start with minus pi over 3. And then from here, we need to go plus pi, plus pi, plus pi. So once again, the answer is actually much easier, plus pi n. That is it. So this is it for now. We are going to add more. For your Delta Math homework, you will have a really good way to visualize these angles. And the only thing, they only give you option of all six trigonometric functions. But don't be scared. If you see cotangent, you just take a reciprocal or secant or cosecant, and then you proceed exactly the same way. Good luck.